Okay, so we are in class 2 of fluid mechanics ME340, and this is video 2. So class 2, video 2, and we're going to talk about the ideal gas law. This is, of course, a refresher. I'm sure you've had it in thermo and physics. So let's take a look at our note sheets and just write it out. Now, of course, you probably had it in chemistry as well, and they did things on a per mole basis, where we're going to keep everything on a per mass basis. So the ideal gas law, or one way to write it out, is the density is equal to the pressure divided by the gas constant divided by the temperature. But let's make this a very explicit. I was going to say specific, but it'll be confusing, right? I'm trying to get this thing to come on. There you go. Zoom. Focus. All right. So the pressure needs to be the absolute pressure, and the temperature needs to be the absolute temperature, right? So I'm not always going to write abs and abs, but we need to remember that. That's like a very common mistake to make that mistake, right? So this is one way of writing it. I kind of prefer this way over here, and I'll write it PV equals MRT. That just rolls off the tongue. That's just one way to just memorize it. PV equals MRT. Now, it's not nRT, because that would be on the number of moles, right? We're talking about the actual mass. So you can see it's actually the density divided by the mass. The mass divided by the volume will give us the density. So these are the same thing. And I could write abs. I'll write it this time, but probably never again. But anyway, we want to remind ourselves that these are the absolute. It has to be an absolute pressure, and it really has to be an absolute temperature. And recall that the absolute temperature in SI are degrees Kelvin, and you add 273 degrees, right? So the absolute, this is the amount of degrees above absolute zero. And then in Rankine, this is one that people forget more often, is 460 degrees. So if you want the absolute temperature, you need to remember to go into Kelvin. If it's SI, go into Rankine if it's US units, right? And if you want to talk, we will cover this in more detail soon, where we talk about pressure, but we really want to remember that absolute pressure, we need to take the gauge pressure, right, gauge, it's supposed to be a subscript, not gauge, gauge pressure, and then add in the atmospheric pressure to that. And now we have the absolute, right? So the gauge pressure, you always think about it, that's just like the pressure you read off of a gauge. And some people will actually call this PSI G, right? The gauge pressure. And then they'll call this PSI A, right? So remember that the atmospheric pressure is 14.7 PSI A, absolute, as opposed to 0 PSI G, right? Gauges generally have 0 as being atmospheric pressure. And it's 101, sometimes 101.4, people will say, but 101 kilopascals, right, is going to be our standard. Now, this gas constant makes for many useful times. You note that you could set these things equal to each other for the same amount of mass. For a constant mass, you can write the pressure times the volume divided by the temperature for one state has to be equal to the pressure times the volume and divided by the temperature for a second state. Like, so you can move from one state to another state as long as it's the same mass. Now there are instances where this gas constant, we have to assume it is constant. I think there are extremes where that constant doesn't really actually hold into. But remember, this is the ideal gas law, right? So an ideal gas is by definition one that has a gas constant that is constant. Right? So make sure, I just want to emphasize, always use absolute pressure and temperature, right? So here's just an example. I like to have examples as so continuing on from here. I'll try to have an example in every video at least to have this one. But we have a compressed air tank, and we know the volume, and we know we've measured the temperature, and we're going to treat the atmospheric temperature as 14.7, right? So when the gauge reads 50 psi, which would be aka PSIG, right? Another way of saying PSI. Anytime they leave it off, there's a good chance they mean the gauge pressure, right? But if you're in doubt, ask, what is the density and how much does the tank weigh? How much the tank weigh, right? So I think that we're going to say how much does the air inside the tank weigh is probably the better way thing. All right, so we're going to go the density and P divided by RT. So now first we have to decide what is R. So we're going to look it up, right? So let's look up the gas constant. Now, the first one I have is I'm going to use what we will be using in on exams, right? So we're going to say 1,716 foot-pounds per slug degree Rankine is what we're going to use, right? So let's go 1,716. These are foot-pounds per slug degree Rankine, and we're going to reconcile that hopefully here in a second. I think that's what I did down below. Yeah, or maybe I did it on a separate sheet. Maybe I did it on the back of a sheet somewhere. I think that's my recollection. I might have. Just well, I want to double check my units somewhere. I know I have it there. Yeah, there it is. Okay. So I'm going to add that in there. Hopefully, I got enough space. So I'm going to take the pressure. Oh, okay. Let's see. The pressure is going to be 50 plus 14.7, and these are pounds per inch squared. Well, I won't always use my units like that. If I'm in a rush, I might leave them out, but it's a good practice to do it. Because I have inches squared here, I want to turn these into a foot basis. So I'm going to multiply by 12 squared, 144. And so that's going to be inches squared per foot squared, right? So there's 12 inches per foot. Therefore, that squared is 144 inches squared per foot squared. I think I went 1 year without explaining 144. It really messed some students up. So I want to make sure it's clear why I used 144. Now we have, because we're trying to get this to match up, right, to get the units to match up. So we have inches squared, so we need to turn that into feet squared so that we can have these feet, right? So we have feet, pounds per slug degree Rankine, right? And then we want to multiply by the temperature, but our temperature is 70, and we have to add to it 460 degrees to get Rankine, right? So if you start to cross these out, you can see we have Rankine and Rankine. That's a good one. We're going to get this answer in slugs, right? So that's fine. It's on the bottom here, so it'll make up on the top. Pounds cancel out, and we're going to have foot here and then a foot squared, so we're going to get a slug per foot squared, so we get 0.01024 slugs per cubic foot, right? And then we want to try, if we want to try to get the weight of the tank, is going to be that density times gravity multiplied by the volume, right? And they told us the volume. Didn't they tell us the volume? Yeah, they did. 0.84 cubic feet. So 0.01024 slug per cubic foot, and 32.2 feet per second squared, and then 0.84 cubic feet. All right, so That's easy enough. The cubic feet come out. But anytime you see this magic combination of a slug times a foot divided by second squared, that, my friend, is a pound. And pound force, if you are doing it in the way that we describe it in the English system, right? So let's call it pound force for right there. All right, so these are the answers, and generally speaking, I would like you, when answering a question, to rewrite the thing out. I have a hard time getting people to do this, but let's, we did it with the minimum of 4 sig figs when calculating the thing, but now for the answer, we could use 3 sig figs. And the reason why we don't want to use more is we don't want to try to imply more certainty than we have, and the reason why we don't want to use less is because you know, it might matter to somebody. Somebody might reuse your stuff at some point, but we want to give the answer out, so we don't want to just chop off some units. Okay, so I'm at the 11-minute mark. I want to try to tackle what is a very annoying trait of the U.S. system that we use. And, you know, go America! I'm a good patriot here, but this really annoying aspect is that we don't just stick with kilograms. We don't use the SI system. And especially for us, we have this pounds mass and slug thing. So one thing you can always remember, is that a slug is much smaller than a pound mass. And you shouldn't say this, but you can basically say that in the English system, 1 pound mass equals 1 pound force. Because you go to the grocery store and you buy a pound of, let's say, ham or something, and sliced ham at the deli. But if it was if you went to England and you'd get like 1 kilogram, or maybe whatever the equivalent to 1 pound would be. So they're using mass units to measure the weight of things. They just kind of a little quirky thing on their side. And so we kind of think of the mass and the weight is kind of interchangeably. So maybe that's one way to think of it. Now, if you accelerate the stuff or whatever, you get a problem with that, because now the force and the mass do not equal each other, right? That is not something we can say, but we can use the gravitational, and they're using 32.17, but we're just going to go 32.2 right here, and we could say that these units work out. But now that's easy enough. But like we have over here on the left is what I just did a second ago, right? Where we say this is a unity conversion factor. And so maybe I need to explain that kind of concept here in the unity conversion factor. So let me actually just pull this up and bring it over to the sides over my other screen so I can reference it and write it down, because I am doing my best to try to keep things straight. So let me see. I will now come back over to here. All right. And so what I just did when I made that slug foot per second squared is what I really wrote F equals MA in my head. And I said a pound force is equal to a slug foot per second squared, right? So anytime I saw these things together, I had that right there. So if I want instead to have the conversion, and I'm going to think about pausing this and trying to write this out, because I'm trying to wing this on the side, right? So I have 1,716 foot-pounds per slug degree Rankine, and I want to turn it into what we have right here, right? So I want to find out how did they get, I'm sorry, right here, 0.3704. I'm going to write down here, PSIA, and maybe I'm going to write that out as a pound per square inch, foot cubed divided by pound mass, degree Rankine. All right, so we're going to try to get there somehow, and we're going to use, let's see which one we're going to use right here. I think I want to use this guy right here. That's going to help me. Yeah, so I'm going to turn, I could use either one of these, I think, but I think I'm going to use that one. Okay, so let me go back over and show my camera, and here's where we're going to try to straighten it out. So remember that I said that this one was a unity conversion factor. I'm going to have to turn a slug into a pound mass. All right, so that's what I need to do is anytime I see this on the bottom, I need to multiply it by something on the top, right? So I am going to use, I lied a second ago, and I didn't lie. I'm going to use this one right here. I'm going to turn a slug into a pound mass. All right, so let me come back over to that. A slug into a pound mass. So I need to multiply it by slug. And a unity conversion factor means I can multiply this. It's just equals to 1, right? And if I had the other situation where I had, maybe I had slug on the top and I wanted to get rid of it, I would just take flip this upside down, right? I'm gonna use 2, right? Even though that's, we're just going to 32.2, right? So we're going to take a slug and divide it by 32.2 in pound mass, and that's going to get rid of my slug, and that's going to get me a pound mass in the denominator. Now I also have an issue here where I have pounds per cubic a square inch, and I have foot cubed right here, right? So what I need to do right here is I need to divide by, okay, so I'll put a division symbol here. Divide by 144 inches squared per foot squared, right? So you're going to see what happens here is we're going to get this foot squared on the bottom is because we're dividing it, and then this is on the bottom here, is going to turn into that cubic feet, and that square inch that we're dividing the pound by is going to be turned into this right here, right? So here is the reconciling of that conversion right in there. So let me here double check it here with my Hewlett-Packard calculator, which I try to get people to, engineering students to consider using. We'll take 1716 divided by 32.2. So what I did is I entered that number, and then I'm writing this, and now I put an operation onto it. Instead of hitting equals, I'm going to hit divide right there, and now I just divided those two, and now I'll divide by 144, and we will see that we get 0.3701, which is pretty darn close, right? So hopefully we've reconciled these two separate methods, right? So in conclusion, or to reiterate, we can use these unity conversion factors, and you could just multiply this, or the reciprocal of it, in which I just mean you flip it upside down and multiply it whenever you want to try to make some conversion, right? To turn one thing into another thing. I think it'll be more useful to do it that way. So the video went longer than I like, but hopefully this will be useful to you. If you get confused, you can come back to this and try to get unconfused. Is that a word? It should be.